Hello, this little lecture will be going over your soft jaw mill part that you'll be doing. This part brings on a new challenge as it requires you to do it in two setups, kind of similar to what you did with the jig bore, but you're actually going to be machining on both sides of the feature. So, and the other thing that it's going to incorporate here is you're actually going to be running this as a production run. So you are going to need to have your work offsets for both operations set before you even make a chip on the part. That's going to require you to put in 2 vices on the mill, and I'll help you arrange those such on a table where it will be effective cutting. So remember though, you will be doing 2 vices. So more than likely this will require a little bit more setup time than what it normally has in other parts. So make sure you allow for time for that. So as far as the part itself goes, what we're looking at as far as features, notice we do have the chamfers, okay, on both sides, even inside this slot. So that's something you're going to have to incorporate. You have some counter bore holes that you're going to be doing with the G13. The drill hole, watch this here. I guess I didn't mention the other thing is that we have, notice your units, we're in metric, so you're going to want to convert everything over into inches more than likely. Now it's not your first part that we've done in metric units, so you should have a pretty good grasp on that, how to convert everything over. So we have those features. So now as we look at the part, we have to determine which features we want to do first. Very typical, what I like to do is do my most critical features last. So if I look at my part, I kind of look it over and I kind of determine what is more critical. You notice here we just have we just have a drill hole and a counter bore hole, but here we do have a pretty tight tolerance slot. So I would more than likely do this feature first, okay? So knowing that now, we're going to do that. So what you're going to want to do is mill the outside rough and finish just a little bit past halfway, okay? So if you got 45, half of that would be 22 and a half. So if you went down 22 millimeters, such, and if you converted that over, you're looking at about a 0.866 depth. So if we went down to 0.9, we should be good. We have 1 inch long, half-inch carbide cutting flutes. So you want to make sure you have one of those, not a shorter, like a regrind or nothing. So you want to make sure you have a 1 inch long cutting flutes. And then when you flip the part over, you're going to machine off the other side, and hopefully they'll match up. Okay, so that'll take care of that part. One thing you do want to watch out for is where your 0, 0 is going to be. Let me see if I can flip this around. Okay. So if you notice, it's a symmetrical part, okay? I've had students use all different types of 0, 0s. Being that it's a symmetrical part, we are coming off of here. Now, typically I preach that not to change that part 0. So to go along with that theme, I would pretty much keep that as my part 0. Now, even when I flip it over, like I said, it's a symmetrical part, so I can maintain that same 0. So when I machine around that outside, I can pretty much copy and paste that feature in, or those cutting passes along with my chamfer tool into my second operation, as long as I maintain that 0, 0. So keep that in mind, and you're going to want to describe where your 0, 0s are for both work offsets up at the top of your program, so you know how to do that setup. Okay, so like I say, that the top isn't really nothing, I guess, too critical. How you're going to go about doing it. So you're going to have your roughing pass, your carbide finish. Probably do this in 3 passes. Carbide, maybe you can get away with 2 passes. Maybe if you want to keep the 3, that's fine. 1 pass, you're probably going to end up with some chatter if you try to take that whole 900 thousandths. And then you also have your chamfer tool. That obviously can be done in 1 pass. So you're going to have those 3 features on the outside. And then along with your drill and your counter bore and then your face mill. So your face mill, I do want to talk something a little bit. Remember, keep in mind that we want to do this as a production run. We don't want to take a cut with our face mill, take a measurement, see what we want to take off, and then go from there. We want everything set up as if we're making 100 of these parts, and you want to go from there. So notice the stock that we're going to be using, 2 1/4 inch thick. Our finish is 45 millimeters, so if we take that, convert that over, that's 1.772. Okay. So being that I want to take this all off, like I said, I want to have multiple passes in my Z depth. Okay. I want to have those programmed in. Typically, we just have one at Z0. Okay. So if we're first starting at 2.25, my finish is at 1.772. That means I'm going to be taking off roughly 478, almost a half an inch. Okay, now that's total. I want to take off about half of that on each side. So that leaves me with 239 approximately on both sides. Okay, so this is the picture. I'm going to try to draw this here. Let's top my part. Okay, so basically what we're saying is from here to here, I want to take off 239 thousandths. Okay, it's too much to take off in one pass. But I also want to incorporate a roughing pass and a finish pass to get a little bit better cut. So my last pass, I still want to be at Z equals 0. Okay, that's my very last pass. I know that for sure. I want to take a finish pass, let's say of 30 thousandths. Now, we're going to be programming this in a positive value. Okay, so plus 0.3, that's going to be my finish. That's going to be for my finish pass. Okay, so that leaves me with about 210 thousandths. So that means if I took off about 70 thousandths, I have pretty good equal cuts. The machine will be able to take it. So I'm going to have this pass at 0.01, I'm sorry, bad math. You heard me say before, simple math kills. Now you erase this. That was 0.03 for my finish. Okay. This is going to be 0.10, 0.17. Okay. Now I don't need a pass at 210 because that's going to take it off right here. Okay. So when I face off, I'm going to have one pass. That's my first pass. Second, third, and then this will be my fourth pass. So I'm going to have 3 roughing passes and 4 finish passes. So basically all you're going to have to do, and there's 2 ways to go about it, you're going to come down. My first pass is going to be a positive 170, cut across. You can cut straight down. Some people like rapiding up, coming over, and then you go back and forth. So you're going to have 4 passes and then cut it out like that. Now, if you look on your assignment sheet, that last pass needs to be at a different RPMs and a different feed rate. If you remember machining concepts, better feed rate, your faster RPM, slower feed rate. So you can increase your RPMs right here by just simply putting an S code with a faster, and then when you hit G01 at Z0, you can put in a different feed rate that would be a little bit slower. So you're going to do that for both sides. And you're going to establish your 0-0, like I said, before you even make a chip for your second operation. And we'll go over that when you actually do the setup part. But the important thing to remember here is to make these all positive numbers. Okay. So the only thing that you might do different when you have that G43H1, more than likely Z.1, you might just use Z.3 or Z.2 so you make sure you stay above your part. Okay. So that gets you down to that height. You flip it over, you're going to have that again in there. Like I said, if you do the 0-0 correctly, you get to copy and paste your chamfer. And the only thing you're left with then is your 13 millimeter slot. Now, one thing that you don't want to do there, 13 millimeters is just a little bit over a half inch, okay? What you don't want to do is just take one pass down with a half-inch end mill and call it good. Or even if you took cutter comp and came down and come over and removed this up here, because what you're going to end up with is your tool pressure is going to be the width of the tool here, and then when you come back across, it's going to be basically nothing because you're only taking off a few thousandths. So what I want you to use there is a 3/8 carbide end mill. All right, and you're going to be making 2 passes down the center. Okay, go right down the center. If you want to pick up and go back, so you're going to do 2 passes down the center. Okay, now when you're doing that, you got to remember you're going to be roughing, so you want to be using 300 surface feet per minute and a 1,000th chip load. Okay, for your speeds and feeds. Okay, so now we removed the majority of the material out of that middle. Okay, and the only thing we have left now is a little bit on that outside. This is where we're going to turn on our cutter comp. So depending on where you end up, it's just basically like you've done before, cutter comp up, cut over, come back, cancel your cutter comp, and that gets you your size. Now, whoops, sorry about that. So once you do that, you rough that all out for your finish now, then you can go back up to 500 surface feet and a 2,000 chip load. So you increase your RPMs and give you a better finish. And then also don't forget the program in for the chamfer, which obviously would be a tool change, and then come back in for that. So you should be able to incorporate that chamfer when you do the chamfer on the outside. Okay, you just might have to move some things around, but you do remember you do want to minimize tool changes. So like I said, a couple new things that second setup. But if you have any questions, please come and see me. Otherwise, good luck.